Let's start with your overall view. How does your company define MLOps, and why is it important for delivering ML products?
Sure. For us, MLOps is the intersection of ML, DevOps, and data engineering, focused on shipping reliable ML features faster while keeping quality measurable.
How does your engineering team collaborate with data scientists during the experimentation phase?
During experimentation, we pair each data scientist with a platform engineer. We share a dev container, so code runs identically on laptops and build agents.
Can you describe the toolchain you use for data versioning and experiment tracking?
We use DVC for data versioning and MLflow to log parameters, metrics, and artifacts. Each experiment is tied to a Git commit and a DVC data hash.
What CI/CD practices have you adopted specifically for ML workflows?
We extended GitHub Actions with reusable workflows that spin up GPU runners, run training jobs, and push artifacts to the model registry.
How do you containerize and package your models before deployment?
We build multi-stage Docker files, first stage for training dependencies, second stage as a slim inference image with only the model and runtime libs.
Which orchestrator do you rely on, Kubernetes X or something else, and why?
We run everything on Kubernetes because it gives us auto-scaling and GPU scheduling out of the box. Plus our SREs already manage K8's clusters.
How do you manage feature stores and ensure consistency between training and serving data?
We adopted Feast as our feature store, so both training notebooks and online inference hit the same definitions backed by Redis and BigQuery.
Walk me through your model deployment pipeline from commit to production inference.
A merged PR triggers the pipeline. Unit tests right arrow training on Kubeflow pipelines right arrow model evaluation right arrow if it passes gates. The image is tagged and deployed via Argo CD.
How do you implement automated testing for models beyond unit tests for code?
We add PyTest-based data checks, grade expectation suites, and model-specific performance tests that compare against baseline metrics.
What metrics do you monitor in production to ensure model health?
We collect latency, throughput, accuracy, and a real-time PSI data drift metric with Prometheus exporters feeding Grafana dashboards.
Have you implemented any canary or shadow deployment strategies for model rollouts?
Yes. We use hidden shadow routing first. 5% of traffic is mirrored to the new model while responses are discarded, but metrics are logged.
How do you handle model rollback if performance degrades?
Rollback is a Helm chart rollback away. Plus, in Argo rollouts, we keep the last 3 stable revisions tagged.
What's your approach to managing model drift and data drift over time?
We schedule a weekly data quality scan. If drift crosses a threshold, an Airflow DAG kicks off for training automatically.
How do you secure your ML pipeline, especially concerning sensitive data?
Sensitive features are encrypted in transit, and we use HashiCorp Vault to inject secrets into training pods.
Can you share your experience integrating model explainability tools into the workflow?
We integrate Captum for PyTorch models and SHAP for tree models. Explanations are stored alongside predictions for audit.
Which governance or compliance frameworks guide your MLOps practice? HIPAA, GDPR, etc.
We comply with GDPR, so every prediction log is linked to a data consent ID and can be purged via an automated pipeline.
How do you keep track of experiment lineage and reproduce past results?
MLflow artifacts plus DVC data snapshots let us rerun exactly the same code and data. We've done it successfully even after 6 months.
Have you faced challenges scaling real-time inference, and how did you solve them?
Yes, our recommendation model latency spiked at the 99th percentile. We switched from CPU to GPU serving using Triton Inference Server.
What role does infrastructure as code play in your MLOps stack?
All infra definitions, AKS clusters, IAM roles, S3 buckets live in Terraform, so rollbacks are version controlled.
How do you budget cloud resources for training versus serving to control costs?
We use AWS Cost Explorer tags and Kubecost to separate spend. Scheduled scaling shuts down training nodes after hours.
Can you talk about any incidents where a model caused user-visible issues in production?
A misconfigured preprocessing step output not NS, which propagated and returned blank screens to users. We traced it within minutes via centralized logging.
How did your incident response process handle that, and what did you learn?
We declared a SEV2, used a Slack war room, reverted to the previous model, and added a new validation step that blocks NA-NS.
How do you ensure coordination between ML engineers and DevOps for shared infra changes?
We run a weekly joint planning session. Any kube-level changes get reviewed by both infra and ML platform owners.
What tools do you use for hyperparameter tuning at scale?
We rely on Optuna with a Kubernetes executor. Trials run in parallel across spot instances, cutting costs by 60%.
Have you adopted any model registry solution, and how does it integrate with CI/CD?
Yes, we host MLflow model registry. Once a model is transitioned to staging, our CD pipeline can pick it up automatically.
What's your strategy for retraining schedules, cron jobs, event-based, or manual triggers?
Most retrains are event-based. When fresh labeled data lands in S3, we trigger a retrain. Some SLA critical models have nightly cron retrains.
How do you manage multi-tenancy or multiple models serving on the same cluster?
We use Selden Core multi-model serving. Each model mounts its own volume with weights and shares the same inference container.
Do you leverage serverless inference services? If so, when do you choose them?
For low-traffic models, we deploy to AWS Lambda using the new 10 GB memory tier. Cold starts are still acceptable below 500 ms.
How do you document your MLOps processes so new team members can ramp up quickly?
We maintain an internal Confluence playbook with diagrams, sequence charts, and step-by-step runbooks for every pipeline stage.
Finally, if you could redesign your MLOps pipeline today, what would you change first and why?
I'd adopt a unified metadata store like Vertex AI first, to remove our current patchwork of MLflow plus DVC plus Feast connections.